Hello everyone, good evening. So, I hope I am visible and audible to everyone. Hi Bishal. Yes, education world, I am excited too. Alright, alright. Sonali. Yes, Sonali, I can see that. Alright, alright. So, I hope there is no glitch at all. Yes, hi Kashalya Devi. Hello Naz, always learning. Alright, so everybody can hear me and see me. Good evening Harshita. Hello Mohini. Alright, so there is no glitch at all, so we can start. A very warm welcome to yet another wonderful session. My name is Khushbu. So what are we going to learn today? So today's session is a concept session 1 on real numbers. So we have already done a bridge session on real numbers and we discussed a few questions. There was a quiz as well, right? Alright, so today we will be covering a few topics of this chapter. Yes. Alright, so first let me walk you through the flow of the session, what all we are going to discuss today. So first we will start off our session with the topic Euclid's division lemma, followed by Euclid's division algorithm. And then we will discuss what's the difference between prime numbers and composite numbers. And after that we will talk about the fundamental theorem of arithmetic. And then we will learn what's the difference between HCF and LCM. We all know how to find this out though. And at last, we'll be talking about applications of fundamental theorem of arithmetic, and then we will take a quick look at the summary. Alright. Alright. So let's get started. But before that, I want you to subscribe the channel so that you do not miss any new updates from us. So that you will keep getting the notifications also about the upcoming chapters, right? Alright, so let's get started. Now, what we are going to do is we are going to enter this classroom. Alright, so many students are here and students are excited for this chapter. So they are asking what's new in this chapter. The teacher says, first let's start with Euclid's division lemma. Alright, so let's start off with our first topic. So what is Euclid's division lemma? It's basically already a proven statement which is used to, which is applied on different things. Like here you're already aware of this. Let's take an example, 7 equals to 3 times 2 plus 1. So what is happening here? 7 is the dividend, 3 is the divisor, 2 is the quotient and 1 is the remainder. This is Euclid's division lemma which we have been learning for the past few years, right? You all know that. Dividend is equal to divisor into quotient plus remainder. But now in this 10th grade, we are denoting this dividend with A, divisor with B, quotient with Q and remainder with R. So I am sure that gradually you will also get familiarized, you will also get used to this form of division lemma. Yes? Yes. Alright. That's amazing, Naz. Yes, Harshita. That's good. I hear this very less from the students who say that their favorite subject is maths. Not AB plus R. Not AB plus R, it is written like A equals to, I think this yellow won't be visible here. So A equals to BQ plus R, right? Right. So that's what Euclid's division lemma is. So this is another form of this only that you've already learned, dividend equals to divisor into quotient plus remainder. Alright. So let's take a look at the mathematical definition of this. So according to Euclid's division lemma, if we have two positive integers, let's say A and B, then there exist unique integers Q and R which will satisfy this condition A equal to BQ plus R. Now we need to remember one thing that here A and B both have to be integers, right? And these two would be unique integers. But there is a restriction that you need to keep in mind that R would be greater than equal to 0 but less than B. So whatever the value of B is, let's say if I talk about the value of B over here is, let's say it is 2. So R can take values because R is greater than equal to 0 but less than 2, right? So R will take values 0, 1 and 2. I'm sorry, not 2 because it is lesser than 2, 0 and 1. R will take values 0 and 1 in that case. I hope this is clear to everyone because sometimes we are asked questions in the on this topic. Yes. Wow, great Varshini. That's nice. Yes. Alright, so I hope this is clear to everyone, right? So let's try out a question based on this to check your understanding. So in the question, a equal to b times q plus r, where a is a positive integer and b is 5. The value of r can be, you can see 4 options over here. Quickly tell me, what could be the value of r in this case? Crystal clear? Yes, Naz? So integers will have different values. Yes, that's unique integers. Wow, Harshita. I feel so good when you say that you like maths. Harshita is saying it's going to be 4. Shruti 4. Manoj says B. So everybody is saying it's 4. That's going to be B. Option B, right? Alright, let's take a look at the solution for this question. So basically we have A equal to BQ plus R, right? And as I said, there is a restriction, R would be greater than equal to 0, less than B. In fact, we have just started with grade 10. Once we are done with this chapter, if you try out questions from different books, you will find out, basic, 1 markers or 2 markers on this concept. Generally, and the questions are basically based on this restriction that we are using here. So B is 5. So as I said, R can be greater than equal to 0 but lesser than 5. So it can take values 0, 1, 2, 3 and 4, right? So the value of R in this case would be what? Among the options, what can we take? The value of R can be 5, we cannot take 6, we cannot take 8, we cannot take, so that's going to be 4, which is our option B. So you all have understood this, right? That option B is the right answer. No doubt still here? I can see that everyone is saying 4, 4, 4. Alright, awesome. Let's try out one more question. So by what number should 533 be divided to get 33 as the quotient and 5 as the remainder? Quickly tell me. Using this Euclid's division lemma, you have to use that only. Tell me what the right answer is going to be. Yes. Easy peasy lemon squeezy? Yes. These topics, see, if you understand the concepts well, it becomes really simple for you to apply that in the questions. And when you apply those concepts in question, then you get a clear understanding. Yes, quickly I'm waiting. Or shall I tell you the solution? But first I want to see what have you understood. Urmila says it's 18, option A. Alright. Madhav says 18, Sompali 28, Ishan, it's C 16. Different answers you are giving. Okay, let me tell you the solution then. So A equals to BQ plus R, that's Euclid's division lemma. A over here, by what number should 533 be divided? So that's the dividend, which is basically A over here. To get 33 as quotient, we don't know by what it should be divided, we need to find B, right? 33 should be the question and 5 as the remainder, so R is 5. So this is going to be 33B plus 528 if I take this to the other side. So B would be equal to 16 in this case. That means option C, that's going to be the right answer. Yes, Prakhar, Nisha, Music Factory. Yes. I hope this is clear to everyone, right? No doubt still here? Alright. Let's move ahead. So this was about Euclid's division lemma. Now what we will be discussing, we will be talking about Euclid's division algorithm. Bishal, no ma'am, you have a doubt. Okay, let's go back, let's quickly see. So what we are doing here, by simply, it's by what number we divide this to get quotient as 33 and 5 as remainder. So I'm just putting everything in this equation over here. No doubt. Okay, so whenever you have no doubts, please write no doubt. Don't just write no. I get confused whether you have a doubt or not. Alright. Alright, Bishal, understood. Yes. Alright, so now we'll be discussing Euclid's division algorithm. Alright. So what's Euclid's division algorithm is? So algorithm is basically, I would say, its application, the lemma that you have learned, right? So when we talk about two positive integers A and B, where A is greater than B, then we will be using Euclid's division lemma. According to that, A is equal to BQ plus R. That's what Euclid's division lemma says, and R would be greater than equal to 0 but less than B. So if R is not equal to 0, in that case, what do we say? That we have to apply Euclid's division lemma to B and R, right? We keep applying it, we keep solving it. But if R is equal to 0, in that case what happens? In that case we get the HCF as B. To get a better understanding, what I'm trying to explain you here is because it is all in the generalized form, right? So let's take a quick look at the question. it will be easier for you to understand. Using Euclid's division algorithm, find the HCF of 144 and 264. So two numbers are here, right? Question is asking you to find out HCM using this algorithm. So out of these two numbers, A and B, again, as we said, we have two numbers A and B, right? So first, we will write Euclid's division lemma. So anyways, as your paper is going to be subjective, every step has to be mentioned. When we are using Euclid's division lemma, you have to mention it first, right? So A equal to BQ plus R, where R is greater than or equal to 0 but lesser than B. Then we will replace A and B by their values. So what is A and B going to be in this case? Can you tell me what would be A here, what would be B here? Quickly. Oh, Varshini has given the answer. Wow. It's so quick. Quickly tell me, out of this 144 and 264, what are A and B going to be? I think some students are now joining. Yes, good evening, Adarsh. Yes, quickly. A would be 264, B 144. Yes, right, because I said A should be greater than B. So A is 264, B 144. Now I am applying Euclid's division lemma using this equation here. So A is 264, B is 144 times Q plus R, right? We will write like this. So we will solve this until we get R equal to 0. So what are the steps going to be? So this is our first step. 264 is equal to 144 into 1 plus 120. We are simply doing the division. Then this 144, which is the divisor here, it becomes the dividend, and this remainder becomes the divisor, times 1 plus 24. And then we have 120 equals to 24 times 5 plus 0. Are you able to understand what all steps we have done here? So I think you will be able to better understand this if I show you. So we have 264 here and 144 here. So 144 times 1 is 144, right? What do I get here? I am simply getting 120. And again we make this thing, right? And we write here 144 now. So can you see this 120 was the remainder. This became the divisor, and over here this 144 was the divisor, and this becomes the dividend over here, right? How this is changing. See, I cannot say that is it going to be subjective or not, because no guidelines have come for this year. So still just prepare according to the subjective paper, rest it can be seen later, right? If we get any guidelines, any new guidelines, anything from the CBSE. I'm sure that your schools have started, so your teachers must be explaining you each and everything, that how to write the steps and all. So in between we have poll questions, don't worry. Krishna Vini. Alright, so 120 plus, 120 times 1 is 120, you get 24. Again I take 120 down here and we get 120 times 5, that's 120. When I get 0 in the remainder, then what happens? What happens here is this divisor, this last divisor becomes your HCF. So HCF in this case is going to be what? It's going to be 24. I hope this is clear to everyone, yes? So you can also try out different questions, like I showed you how to apply the Euclid's division algorithm in the questions. In your NCERT book also you have some questions, you can try out those questions using this method. No Menti today. Yes, absolutely. See, more or less the topics are same, right? But you might have different questions. Doesn't matter, even in the maths you have different questions, right? Only the digits would be changed, or it will be a little bit twisted, right? The basic concept is same. Alright, let's move ahead. Let's try out another question so that every odd positive integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5. We need to show this thing. So whenever you come across questions like this, your first step should be you need to identify what is required to be shown. Yes. Alright, so here we need to show that odd positive integers, every odd positive integer is either of this form, 6q plus 1, 6q plus 3 or 6q plus 5. This is what we need to show. So first, I am telling you how to start, how to go about these questions, right? Where you need to start from. Then we will write the Euclid's division lemma, right? Which is A equal to BQ plus R and R is greater than or equal to 0 lesser than B. And we know that. Now we will assign the value for B over here. So it's already mentioned 6q, 6q, 6q. And what is the form? Form is A equal to BQ plus R. So it is 6q. That means in place of B, we have got 6 over here. So I will say that B would be 6 in this case, right? So A is equal to 6 plus R. Now we know that there is a restriction that R is greater than or equal to 0 but lesser than B. That means R would be greater than or equal to 0 but less than 6, right? So it means R, we can assign different values to R. Which values? 0, 1, 2, 3, 4, 5. Since it is greater than equal to 0 but less than 6. So any doubts you have till here, quickly tell me. There are no doubts, so we can move ahead. Knowledge hub, what is 4? Yes, what is 4? Yes, Sunita, 0, 1, 2, 3, 4, 5. So these would be the values for R, right? Yes. All right, all right. So what we can say here is that simply I can say that since A is equal to 6Q plus R and R will have all these values, right? All these values over here. So what we can say is for R equal to 0, A would be equal to 6Q because 6Q plus 0 would be 6Q, right? So I can write it as 2 times 3Q. What does it mean? 2 times 3Q means it is multiplied by it. So it is obviously divisible by 2 times 3Q, it is divisible by 2 over here. So this number I can say similarly. If I put R1 here, A equal to 6Q plus 1, this is A equal to 6Q plus 2. If I take 2 common, that would be 2 times 3Q plus 1. Similarly for this, for every example we are just putting it, right? Now what you can figure out from here is it 2 times 3Q? That means it is divisible by 2. It is going to be even. It is representing an even number. If you talk about this form, 6Q is divisible by 2, we know that, we just saw here. But if I add 1 to it, it's going to be odd. Similarly, you have taken 2 common from here. So it is divisible by 2, that's going to be even. Here it is 6Q plus 3, this is divisible by 2, but plus 3 makes it odd. Yes? Similarly for this example, 2 times 3Q plus 2, this is even and this is odd over here, and you need to write the final statement properly at the end. Statements are important or not? Which statements? Are you talking about this thing like whatever we have written here? So we have to mention each and everything, whatever I have written here. Rohit Kumar, no doubt, yes? Alright, alright. So this was about the Euclid's division algorithm, right? Now let's see what do we have next. So now we'll be discussing about prime versus composite numbers. So I'm sure prime numbers we all have heard about. So what are composite numbers actually? So first we will just take a quick look at all the numbers from 1 to 10. So 1 is such a number which is neither prime nor composite, right? Yes. Don't think about all these things, Hemlata. Just focus on studying right now. We will get a clarity on all these things. Vishal, got it? Yes, great. So 2 could be written as 1 times 2, 3 could be written as 1 times 3, 4 could be written as 1 times 2 times 2, 5 could be written as 1 times 5, 6 could be written. Can you see that how we have splitted all these numbers over here, right? So what are we trying to show here is that basically we have splitted all these numbers. Yes. So we have split all these numbers. So what we are trying to show here is that prime number has exactly 2 factors, 1 and the number itself. Whereas if you talk about the composite number, it has more than 2 factors other than 1 and the number. Like here 2, that's 2 times 1. It is the number itself and 1. It is 3, 1 and the number itself. It is 5, 1 and the number itself. So all these are nothing but these are the prime numbers. When you talk about composite numbers, so you have 1, other than 1, the number itself, and more than 2 factors you will have. So here 2 times 2, right? Other than the number, 4 is anyways a factor, 1 is a factor, 2 is also there. Times like 6, it is 3 times 2. So like this, we can say that this is the differentiation between the prime and composite numbers. So I hope this is clear to everyone, right? No doubt still here. Alright, alright. So this was about the prime versus composite numbers. Now we will learn about the fundamental theorem of arithmetic. Alright, let's take a look at this. So first let's take a look at the mathematical statement. So every composite number can be expressed as a product of primes. Yes. And this factorization is unique apart from the order. So what does this mean actually? If you talk about 20, let's say, right? 20 could be written as 2 times 10, right? 10 could be written as 2 times 5 and 5 could be written as 5 times 1, right? So here if you see these numbers over here, these 20, 65 and 93 are composite numbers. Look at their prime factorization. It's 2 times 5. All these are primes, 2 and 5 are prime numbers. So they can be expressed as product as primes, and this factorization is going to be unique because if I multiply these numbers, I'm going to get 20. I will not get any other number. That's why this factorization is unique. Apart from the order doesn't matter. Right? 65, 5 times 13, both are primes, right? It can be written as product of primes. 3 times 31, it's 93, both are primes. Yes. All right, all right. So I hope this is clear to everyone, right? So every composite number we can, so composite number is something that you can express as a product of primes. Yes. That's okay, Aditi. So you have missed a few topics, but you can watch the recorded session later on. So I hope this is clear to everyone, the fundamental theorem of arithmetic. Yes. So for questions, Varshini, don't worry. We will have sessions on the questions as well, right? So there are going to be practice sessions also. So everything will be covered. Don't worry about that. Alright, let's try out this question. Express 60 as a product of its prime factors. So this is going to be very simple. We all know that, right? By using the prime factorization method, I can say it is 2 times 30, right? Then 2 times 15 is 30. This is 3 times 5 and 5 times 1. So 60 could be written as 2 times 2 times 3 times 5, which is 2 square times 3 times 5. That's how it could be written as product of its prime factors. No, Durga Denison, no. So I hope everyone is clear about this, right? The prime factorization, the fundamental theorem of arithmetic. Right, Harshita? Alright, let's quickly try out a question. Explain why 7 times 11 times 13 plus 13 and 7 times 6 times 5 times 4 times 3 times 2 plus 1 times 1 plus 5 are composite numbers. Why can we call them composite numbers? Alright. So if you look at this expression, 7 times 11 times 13 plus 13. Yes, Vishal, got it? Harshita? Alright, clear. So if I take 13 common from here, what do I get? 7 times 11 times 1 plus 1. This is clear to everyone, this step? I am just taking 13 common from here. Yes, Tanvi? Yes, yes, Harshita, right. So this is just for your practice, right? Yes, we are just taking common. Alright. So what we can do is, simply I can write this as 77 plus 1, 13 times 77 plus 1, which could be written as 13 times 78. So hence we can say that it is a composite number because they are nothing but they can be written as product of primes, right? Yes, I hope this is clear to everyone. Now talking about the next one, in this expression also, what we can take common, we can see 5 over here. From here till here, 5 is common, right? This is common amongst them. Because 13 was common at that. You see from here till here, 13 was common. Because I need to show them as a product of primes. So here I am taking 5 common. So I will be left with all the other things that we have here. That's 1008 plus 1. That's going to be 5 into 1009. This is nothing but, yes, this is nothing but we are showing them as product of primes over here, right? So this is a composite number. So here 5 was common. Alright, so I hope everybody is clear with the fundamental theorem of arithmetic. Quickly give me thumbs up, smileys in the comment section if it is clear to you. Yes. Quickly tell me so that I can move ahead. So we are taking common from here to just simplify this, right? Simplification would be a lot easier. Varshini Reddy is giving so many smileys. Wow. Alright, so I hope this is clear to everyone. Yes, Harshita, Durga Denison, Aditi. Alright, alright. Education world. Okay, alright. Awesome. So let's move ahead. So now we will be discussing about HCF versus LCM. So we all know how to find out HCF and LCM, right? We have been doing it for the past, I would say, 3-4 years, right? In the previous classes as well, we have done it. So let's say if I consider two numbers, 26 and 91. Let's do their prime factorization first. So for 26, it's going to be 2 times 13, 13, 1. Thank you, Bishal. All right. I can see Sanjay Ram is giving thumbs up. So previous topic is clear to everyone. Similarly, I'll do the prime factorization for 91 also. So 7 times 13 is 91, 13 times 1. So what we can do is 26 could be written as 2 times 13, 91 could be written as 7 times 13. So if I have to find out the LCM, which is least common multiple of these two numbers, what would I do? Simply for LCM, what we do is we simply write down all the kind of numbers that both of these have. So they have different numbers 2, 7 and 13. So that's going to be your LCM, which would be equals to 182. So what we do is, when we are finding out LCM using this prime factorization method like this, we just write down the different numbers that we have, right? Let's say, let me give you an example, just taking an example. Let's say you have a number wherein in prime factorization 13 was coming twice, in the another one you have this, right? So in that case, what would be the LCM? In that case, LCM would be, as I said, write the different kind of numbers that you have. Then we look for the powers. Here also we have 13, here also we have 13, but here we have got 13 twice, so I'll put a power over here. So after multiplying, whatever you get, that would be your least common multiple. I hope this is clear to everyone, right? Talking about the HCF, that's highest common factor. As the name suggests, you have to take the highest common factor. What is common amongst them? That's 13, so HCF is 13. Yes, Varshini, as I said, we will be covering everything. It is just the very first concept session, right? Few topics I am just covering today. We will come up with the NCERT questions also, right? From different books also questions will be covered. Don't worry about that. Yes, 13. So I hope everyone is clear with LCM, right? How we are taking the LCM here. Like how to find out HCF and LCM if we are using the prime factorization method. Wow, amazing, Vishal. That's good. This is clear, great. Now let's find out the relation between HCF and LCM. So there is a relation basically, and trust me, this relation helps you to solve a particular type of question so quickly. So let's say we have two numbers A and B. So HCF and LCM of two numbers, right? The product of HCF and LCM of two numbers is equal to the product of the numbers. Yes. Hemlata, for LCM highest power, HCF lowest power, highest power, HCF lowest power. This is another way to remember it. Yeah, that works. Yeah. Yes. Alright. So let's say we have two numbers A and B. So the product of two numbers is equal to the product of their HCF and LCM. Yes, right, Varshini. Right. So let's take example to understand this. You will have a better understanding. Let's say we have two numbers 10 and 15, right? Now if I do their prime factorization, we get 2 times 5, this is 3 times 5, right? So what the HCF of 15 and 10 going to be? Simply, you would say, ma'am, HCF, highest common factor, that's going to be 5. And what the LCM is going to be? As I told you, write every type of number, then we look for their powers, everyone is coming only once. So we will say it's 30, right? So we have HCF and LCM. Now if I have to check it, you can verify this. HCF times LCM is equal to product of two numbers. You see 5 times 30, product of numbers is 150. LHS and RHS are equal. Right. So this relation would be, I would say, very good questions can be formed using this relation. Yes. So you would come across some very different, some twisted questions in different books. In NCERT, you will find only straightforward questions, the basic questions. Alright, so let's try out a question. Let's try applying this concept in a question. You will get a better understanding then. Find the LCM and HCF of 26 and 91 and verify that LCM times HCF is equal to product of two numbers. So we have the two numbers. First, we will be finding out their HCF and LCM. So LCM for this would be 182, HCF would be 13, right? If I have to verify these, their product would be what? Product of numbers, I check this, I get 2366. Now let's multiply their HCF and LCM, right? LCM is 182, HCF is 13. Again, I am getting 2366. So we can say that HCF times LCM is equal to product of two numbers. Questions can be tricky. Yes, there are tricky questions on this topic. Right now, we have just started with our very first session. You have just started learning this concept. Obviously, I cannot give you tricky questions in the very first session, right? Once you get used to of applying these concepts in simple questions, then gradually we'll increase the level. Don't worry. We will be covering difficult, critical questions as well. So what we are trying to understand here is that when we are talking about two numbers, their product would be equal to the product of their HCF and LCM. Yes? So this is what this topic is about. Let's try out one more question. Now you tell me. The HCF of the two numbers is 23 and their LCM is 1449. If one of the numbers is 161, find the other. Yes. then the one way. Yes, this is very easy. Quickly tell me, what the other number is going to be in this case? I will not tell you the answer. I want to see first whether you have understood this topic or not. Yes, quickly, you have the HCF of two numbers, their LCM is given, you are given one of the numbers. This is simple for a 10th grader, yes. Absolutely, Harshita. That's why the main thing is you need to first understand the concepts well. Give proper time to understand them. Yes, I do. Suvankar, yes. Nisha says it's 207. Sunita 207, then the 207. Alright, let's see the solution now. So HCF over here is 23, LCM is 1449, other number is 161. As I said, let's say other number is P. You can assume any variable for that. We have learned this relation, right? Let's put HCF, LCM, the other number, and P over here. On simplification, what do we get? We get 207, that's the other number. You all are right. So everybody has understood the application of this, right? How to apply this in questions. Yes? Thumbs up, smileys, or any emojis that you like. Yes, Durga Denison, Harshita, Shruti, Varshini. Yes. 207 would be the answer. Now the next question coming up is a little trickier one, but a very interesting question. Alright, let's take a look. So bank locker is locked with a 3-digit code whose first digit is 6. Please understand the question carefully first. If the HCF of the first and the last 2 digits, so last 2 digits are clubbed together, question is specifying it, is 3 and their LCM is 30, find the last 2 digits of the lock code. So do you want me to solve this question or you want to try it first? Yes. How do we get to know HCF or LCM to solve in word problems? Sanjana, you are asking about the applications of this topic. That I will be covering. I'll explain that in detail. There is a trick basically to check this out. So don't worry. We will be learning that in detail. Yes, Aditi. You want to try. Yes, this is a tricky one and very interesting question. Let me see who answers first. Yes, because you won't find this question in your book, right? This is a very different question, you see. Now, I want to see how much you have actually understood because the previous ones were very simple. Sunita is saying the last 2 numbers are 15. Wow, Sunita, how come you got the answer so quickly? Himanshi says 45. Okay, let's check it now. So when we are saying there is a bank locker, 3-digit code, right? First digit is 6. HCF of the first and the last 2 digits, we are clubbing them together. So it's given like this, right? First and the last one, we are clubbing them together means we are considering them as one number, right? So their HCF is 3 and their LCM is 30. So last 2 digits of the lock code are what? So first we write the unknown thing, right? Let's say the last 2 digits together they are representing A. Yes. Yes, Afifa Ikhtiar, identification of HCF LCM. Somebody just asked me the same question a couple of minutes before and I said the same thing. I will tell you the trick for this, don't worry. But you need to wait for the upcoming sessions for that. So write the relation between HCF and LCM first. We know this is the relation now, right? All we will have to do is we just have to plug in all the values that we have, right? 3 times 30 equals to 6 times A, 90 equal to 6A, so A is 15. We're getting a 2-digit number and that's what the last 2 digits are. So we have cracked the code. Wow. So the value is 15. How come you're getting 30, 10? We just saw the application of this relation of HCF and LCM. So we are using that. So I hope this is clear to everyone. Yes? Quickly tell me. No doubt still here? Shruti, yes, 15. Hello Astha, I think you have just joined. So you have missed a lot of topics. You can watch the recorded session later, whatever you have missed. You want me to repeat again? Okay. So Chetan, what we are doing here is, we know one thing, that the bank locker has a 3-digit code. So this is our first digit and we have clubbed these 2 digits together, right? Question is saying HCF of this and the last 2 digits together, their HCF is 3 and their LCM is 30. We know HCF, we know LCM. We know one number, we don't know the other number. Let's say the other number is A. So using this this relation, I can say that 3, HCF is 3, LCM is 30, product of two numbers is 6 times A, you get A 15. You are getting a 2-digit number and we required 2 digits actually. Yes? So, we have cracked the code. It's 615, the final answer. The question was tricky. Yes, that's what I told you. Question is tricky. Yes, I hope this is clear to everyone. No confusions. Whomsoever is saying 10, 13, 30, 15 would be the last 2 digits for this code. Any doubts still here? Yes, quickly thumbs up, smileys, so that I can move ahead. Varshini is giving thumbs up, Durga, no doubts, Yanda, clear, great. Alright, so I hope this is clear to everyone. Alright, I can see thumbs up and smileys now. Alright, so now there is another question that you have to try on your own. Let's see what it is. So product of two numbers is 24 and their HCF is 2, their LCM is. I'm giving you 30 seconds to solve this question. Quickly, you have 4 options over here on the screen. Tell me what the right option is. Vamangi Nayak, Adarsh, Hemlata, this is clear to everyone. Great. Yes, everyone is saying B 12, Nirmali, Pragyansu, Jagadish, Varshini, Aditi. Everyone is saying it's 12. Okay, let's check the answers. So the correct answer for this question is, yes, it's B 12. Alright. So we all have understood. Let's quickly take a look at the solution now. So what we are doing here is product of two numbers is 24, HCF is given. We are using this relation, right, which we have just learned. Let's plug in all the values here. 2 times LCM equals to 24. So LCM would be 12 in that case, right? Yes. Alright. So I hope this is clear to everyone, right? Yes. This is clear to everyone. 12 is the answer for this question. Alright. Let's move ahead. Let's take a look at the next topic now. So now we'll be discussing applications of fundamental theorem of arithmetic. Alright. So again, we can see these two kids here. So what we can see here is that they have got 16 apples over here, right? So now they're discussing, if we try to divide these 16 apples amongst us, so that means total number of apples are 16, number of kids are 2. So each one of them is going to get 8 apples. That's easy, right? So that is very simple question, right? Now what if there are 4 apples? That has to be distributed between them. So in that case, number of apples are 4, kids are 2. So number of apples with each kid is going to be equals to 2, right? So that means that this number, kids were 2 in both the cases. When the number of apples were 16, each kid was getting 8. When the number of apples were 4, each kid was getting 2. So every time it was divided between 2 kids, right? So this 2 over here is dividing 16 also, and this 2 over here is dividing 4 also. So if you analyze this, we can say that 2 is dividing 4 square, that is 16, and 2 is dividing 4 also, right? So this is what the application of fundamental theorem of arithmetic says. So if 2 is dividing 4 square, it implies that it will divide 4 as well, right? Alright, so I hope this is clear to everyone. So let's try out a question. You will get a better understanding. If 7 divides 14 square, then 7 should definitely divide 14. Is this statement going to be true or false? So this is based on the concept that we just learned. Quickly tell me. Yes. Hi Mayank Gaming. Absolutely Hemlata. I think you already know this. Pooja Sehgal, crystal clear. Light Yagami, hi. I think few students are now joining. Yes. Everybody is saying it's true. Right, that's the right answer, because we just learned if a number is dividing, let's say 7 divides 14 square, right? 7 divides 14 square. So this implies that 7 divides 14 as well. This is what we just learned, right? Alright, let's try out one more question. Which of the following is correct if 5 divides A? Option A or option B? Quickly tell me. Yes. Yes, Sonali, obviously true. Yes, hi Sachin. Yes, hi bread. It definitely divides, but which is the right answer? Everyone is saying B. Let's check the answer. So yes, it's option B. What we can see here is that here 5 is dividing C, right? And here 5 is dividing A to get C. So option B, obviously it is correct. So A should have at least 5 as a factor, right? So I hope this is clear. Alright, so we just learned about the fundamental application of fundamental theorem of arithmetic using a real life example, right? The two kids sharing apples. Now let's see that in the language of mathematics. So if P divides A square, this implies that P will divide A also, where A is in positive integer and P is a prime number. Please keep that in your mind that P is a prime number over here. Like the example that I used 2, 2 is a prime number. I used 7, 7 is a prime number. Yes? Right. Thank you, Danda. So this is easy to understand. Now this kid is also saying that's so easy. All right. So according to fundamental theorem of arithmetic, it says that if P divides A square implies P divides A, where A is a positive integer and P is a prime number, and it will use to prove the irrationality of numbers like root 2, root 3 and so on like this. All right. So we have understood. Where are we going to use this actually? Now let's quickly try out a question to check your understanding. 2 root 3 is, you can see 4 options: integer, rational number, irrational, whole number. I'm giving you 30 seconds to answer this. Quickly tell me. Hemlata, so we have a poll question over here. This question, education world. Oh, I can see answers. Shruti, Asmita, Sunita, everyone is saying it's C. C is the right answer. Everyone is so sure. You gave the answer so quickly. Nisha, Aditi, bread. All right, all right. So the correct answer for this question is, yes, it's option C, it's an irrational number. Reason being, 2 is a rational number and root 3 is irrational, and the product of rational and irrational is always irrational. Yes. All right, Bishal. So we have understood this, right? Now students have this question, so how to prove irrationality of a number actually, because we saw that it can be used to prove the irrationality of a number, but how to do that? So we will learn it later. Alright, let's quickly summarize what we have learned now. So first, we started off our session by talking about the Euclid's division lemma, right, which is a proven statement. So we learned that A and B there exist unique numbers Q and R which satisfy the condition A equal to BQ plus R, and this restriction is important here. Then we talked about the Euclid's division algorithm, which is used to find the HCF of two numbers. Then we learned about the fundamental theorem of arithmetic, that every composite number can be expressed as a product of primes, and this factorization is unique apart from the order. We also learned about the relation between HCF and LCM, and we tried out a few questions also on this. And then we talked about the application of fundamental theorem of arithmetic, right? So all these topics we have covered today. Don't worry, we'll be covering the rest of the topics, and the questions that you were asking, different questions, everything will be covered. And just very interesting thing at the end, you know that 22nd April is celebrated every year as the World Earth Day, and more than 1 billion people every year participate in this, because to protect our planet, to make it a better place to live from things like pollution, deforestation, we all are aware of these things. So they participate in the activities like picking up the litter and all. So what you can do is, we should also take an initiative to make our earth a better place to live, right? So whatever you do, whether you make posters, you make videos or photos, you can share it with us. But how to share that? There is a link given in the description below, a Google form link. You can fill that form and attach whatever you want to along with it. Alright, now let's quickly take a look at the homework question. So mason has to install square marble tiles of the largest possible size in a bathroom, measuring 24 feet by 15 feet. What should be the size of the tiles that have to be installed? You can let us know your answers in the comment section after this session. I'm sure that many students have a confusion, just giving you a hint, whether to use HCF or LCM in such kind of word problems. Try this out, I'll tell you the trick, don't worry. So we have got you covered, and we have lined up many more sessions for you from every Monday to Friday to make you exam ready. So don't worry, whatever you are saying, ma'am, this question, that question, everything will be covered. Let me give you a glimpse of the upcoming session. Next session is on Wednesday, 27th April, 7 p.m. I'll be covering real numbers, NCERT Sprint 1. NCERT questions I'll be covering in that. And there is a link for free trial classes as well. Please click on that and get all your doubts clarified instantly during the class. And please like, share and subscribe so that you do not miss any new updates from us. Yes, that's not a chapter of grade 10th bread. Sorry, Lakshmi. Yes, thank you. All right, so I'll see you soon. Thank you so much. Bye-bye.